Okay, so we're going to revisit the graph in one of our previous videos, and we're going to look for a horizontal asymptote. So we've talked about vertical asymptotes, and we've talked about holes. So what we want to do here is we're just going to look at the picture, and then there's a way to actually determine where the actual horizontal asymptote is without looking at the graph. But right now, just to discuss, we're going to look at the graph. So first, what we did for the vertical asymptote is we took our denominator and we factored it. Now, because none of these factors are in the numerator, these are vertical asymptotes. So I have a vertical asymptote at x is equal to 1 and x is equal to -1. My domain is x where x cannot equal 1 or -1. Okay? So notice the domain is not equal to, the vertical asymptote is equal to. Okay? So I'm going to go ahead and draw those in red just so we have those on the graph. Okay, and we use dashed lines to draw those in. So when you draw them in on your graphs, make sure you have a dashed line. So those are vertical asymptotes, and the behavior of the graph is it will get as close as possible to this graph, this dashed red line, without touching it. So all of the black portion of the graph, as it approaches these red lines, it will get so close to it but will never touch. No matter how close we get to -1, it will never touch. And once it hits -1, it doesn't work because that would be 0 in the denominator. Now if we look at the picture, hopefully you're saying to yourself, well, it looks like I have a horizontal asymptote right here, which is correct. Our horizontal asymptote is when y is equal to 0. Remember, horizontal lines are y is equal to, vertical lines are x is equal to. So all of our horizontal asymptotes are going to be a y equal to. And by looking at the graph, the behavior shows us, hey, we have this horizontal asymptote at y is equal to 0. Disregard this little piece in here. We don't have to worry about it for what we talk about. So this is where we find a horizontal asymptote. And we're still going to use dashed lines. I just drew a solid line so we could see that that's where it's at. Okay? So one of the previous videos too, I used this draw function. You can also use a draw function and select a horizontal line and try and gauge where it's at. Okay? So here is, which is in page 492 of your book, when we look for a horizontal asymptote, you need to focus on the degrees of the numerator and the denominator. So in our example, we had 2x over x squared minus 1. So this is a degree of 1 for the polynomial. This is a degree of 2. So I'm looking at the highest power. And that is going to tell us what type of horizontal asymptote that it is. So horizontal asymptote, it's a y equal to equation. So this is horizontal, y is equal to, the slope is equal to 0. So horizontal slope is equal to 0, and it's a y equal to equation. That's what the HOI is for. So the first example is we have a degree in the denominator and the numerator. So if the degree of the numerator, it's getting kind of messy here with all the circles and stuff like that, so I'll erase that. So if the degree in the numerator is less than the degree in the denominator, then y is equal to 0. And that's what we saw in this example. So this is number 1. Number 2, I'm just going to make a function up. It says if the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. And I'm going to do a quick example here that's easy to look at. Well, we have a degree of 2 over degree of 1. So based on this, we have no horizontal asymptote. Well, let's think about the picture of this. This piece would reduce, right? And we would reduce to just x. Well, think about the graph of just x. It's a straight line. There's a hole in the graph, but there's no horizontal asymptote. So that's number 2. Number 3, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the leading coefficient over the leading coefficient. Okay? We have a trick to remember this, but with what you see here, we can create a straightforward example. So if I had 3x cubed minus 1 over x cubed plus 1, the degree is 3 over the degree 3, so our horizontal asymptote is going to equal our leading coefficient over our leading coefficient. So we'd have y is equal to 3 over 1. And we'll do some examples where we have to find all this stuff, but I just kind of wanted to go over the premise. And so there's a quick way that we use to remember this. We have this little trick. We slow, listen, and I call this one South Side of Chicago, just obviously because we're a Chicago suburb, so it makes it a little bit easier. So when we have smaller over larger, and we're always referencing the degrees, we have y is equal to 0. When we have larger over smaller, we have none. So slow, listen, and then South Side of Chicago is same degree over same degree. Y is equal to coefficients, leading coefficient. Let me erase that. Leading coefficient over leading coefficient. So make sure you watch some of the next examples, and we'll see all of these 3 different situations. So we've talked about all the different types of asymptotes. We have horizontal, vertical, and then we have holes. And you need to be sure that you're able to distinguish which is which.